So, Rocco, you can take us away. Rocco is going to perform some tips and tricks. Hopefully it's going to be useful. And we're looking for something, again, that you can use in the daily process of modeling that maybe you didn't know. So give us some feedback as well as you go. I'm going to be up here. If there's questions, I'll handle that. I'll assist Rocco, but Rocco is going to be talking and telling you what he's doing in the same go. Rocco, over to you.
Thank you, Idris. As Idris said, I'm Rocco. I'm an associate applications technician, and I'm going to do some tips and tricks today for you guys. So for this first trick, I wanted to do a handstand, but I'm a bit unfit for that. So I'm going to start here. So we're going to start with SOLIDWORKS part modeling. And as you can see, there's a few things we want to go through. It's going to be thin features, wrapped projected sketches, derived sketches, instant 3D, instant 2D, and split and safe bodies. I want to ask the audience a question. I don't know how many of you guys actually use thin features in your day-to-day. Not.
There's a few hands, but not a lot.
There's a few. Idris, would you say you use thin features often?
Well, it's something that often with extrudes and so on I don't use, but I figured out a few nice things where thin features can actually be useful, especially when we do cuts. So that's why we are going to build on this and show you some nice tricks.
Exactly. So one of the first things we can go and see is to actually extrude. So what is a thin feature? A thin feature is basically an open contour that we use to either extrude or to cut. So to give you guys an example, if I go to my features and extrude this closed contour here, you will see there is a thin feature option, but it's not ticked. SOLIDWORKS automatically assumes that you are not going to use a thin feature, it is closed. So you can go and use it, but for now, for this demonstration purposes, I'm going to leave it. I'm not going to go ahead and tick it. I'm just going to go and click OK.
Part of what we want to show as well as, what we want to focus you on, is the default behavior and how the software reacts and kind of anticipates what you will do. So this is what we do every day, closed contour, solid extrusion. Okay, excellent.
Yes, it is. You're perfectly right there. So I'm going to show you guys what happens when you use an open contour. So if I go to the features again, extrude bar space, and select my open sketch, you'll see that it doesn't close. It just makes a slot here. So it works the same as a normal extrude. You can still go and choose how far it is, and you can go and change the length of it. So if I go and make this 15, it's just going to get a bit thicker. Okay. So now you realize you don't actually want a closed contour. If you have a closed contour, but you want to use thin features. If you want to go and change this option, and you go and edit, you'll see that the thin feature actually disappeared. So SOLIDWORKS recognizes that you have a closed contour, you didn't select thin features, and wants to streamline the process for you. So it's going to take that option away. So the only option to actually get thin features back is to go and delete the feature.
Just before you delete it. Who has been annoyed by that, where you edit a feature, okay, few hands, okay, edit a feature, the thin feature, it's an example, fillets and things work like that as well. There was other options, now you want to change it and you edit the feature and the option is not there anymore, okay, and this is what Rocco is showing. So Rocco, you can continue deleting that feature. That's the only way for that sketch. We're going to keep the sketch and then do it. But the reason why, I asked him to put this in so that I can explain the reason why for you guys. I found out the reason for this when they did a significant change in the algorithm. That was about 2017 around. A significant change in the algorithm that calculates normal fillets on a block. Okay, and I knew this thing is working completely different. It should give me a completely different blend. And I had a part from a customer that I wanted that blend, but the fillet didn't give me that. Then I found out, but he modeled it in an earlier version. Okay, no problem. I now converted that file to 2017. I opened the fillet feature, I edit it, and I rebuild it, and it still gives me the old result. So obviously something wrong. We created a service request, I send it to SOLIDWORKS, I say, why is your software broken? Because you guys tell me your software is broken, I go tell them, hey, your software is broken. And they came back and they said, no, this is intended behavior. So when you build in a feature into our tree, then it actually absorbs a part of that algorithm into the file. That's the intelligence that keeps it parametric and rebuilds. Sometimes when you change it, that new fillet feature is completely different. And it just doesn't just swap it out, because that worked for you. You were happy with it. So if I want to do it, I have to remove it and redo it to use the new algorithm. So with a lot of our features, there's multitude of options. For it to absorb every single thing, our files are going to get massive. Okay. So it does streamline it, and it throws the things that you don't use out of it. That's why you have this behavior. Okay. So I wanted to do this specifically so that you understand this is not just the annoying thing. SOLIDWORKS is broken, it doesn't allow me thin feature. There's a specific reason for it. Okay. The more you understand how the software works and why it does it, you can anticipate what to do to get those things back as well.
I'm going to go to your features and extrude this close contour again to show you guys to just go and select the thin feature, what happens. Like it has said, it happens when you select one selection or option and the other one disappears. So if I go and select this, still 100 like the default, and still the 15 width, I can actually go and see that it is a thin feature, and if I want to go and edit the feature, it is still a thin feature option. I'm going to show you guys another thin feature option you can use. Like we said, you can either go and use the extrude or the cut. So Edith, how many ways can you cut with a thin feature?
Who of you have cut with a thin feature? Okay, there's a few hands. What is the default behavior when I create an open contour? Rocco showed us, he had an open contour, he said extrude, default is then a thin feature, makes sense. What's the default behavior with a cut if I try and cut with an open contour? It's cutting with a plane. Somebody said that. Okay. So, Rocco, let's go into cutting with a thin feature.
Okay. So I'm just going to go and create a line. This is very bad practice. Always define your lines. But I'm just going to go and use a normal line for this. Go to my features and cut extrude.
Remember, I said to you in the beginning, we want to see and we want to get to understand the default behavior of the software with the information that we give it.
Okay. So if I go and change my direction 1 from blind to 3 to through all, you'll see that it is a plane. You'll see this little, you'll notice this little arrow here. That is the direction it's going to cut, which means that everything on this side is going to cut away.
Will it work? Question. There's a lot of murmurs of no. So, because the line does not extend over the part, it cannot cut away. That's the default that it wants to do. So, Rocco, we actually want to cut a slot.
So it is, if you want to cut a slot, you have to actually go and select the thin feature option. And you'll see in the preview that it actually makes a slot for us. Okay. Again, you can go and change the width you wanted. We're just going to keep it for like this.
You
for
can
now.
cut that.
Just going to click OK.
Okay.
And you'll see the slots.
You all know that. You can override the default and go and set it to be a thin feature. Then it takes that contour, assigns thickness to the contour, and it cuts with that volume that it's created.
Edith, can I show you to actually go and if I draw a line across the whole body to cut away?
Take a spline for us. Sketch a spline.
A spline.
Yeah. You can take your line if you're not happy with the spline.
Okay. I'm just going to use a line just to save on time. And I'm just going to draw a line like this across. And go and cut extrude. You'll see now that, again, for the default, it wants to use the plane. You'll see the arrow here. I'm just going to use the through all. And if I cut, everything from this side of the arrow is going to fall away. It's going to disappear.
Let's edit that feature. And if we realized it's cut the wrong side away, just change the direction. We'll see our arrow points in a different direction. And then if we apply it again, you'll see it's the other side that will be removed. So we had answers of it making a surface body. No, it's not making a surface body. But what it does, it creates effectively like a surface cut, and then it trims the body. As long as the cut go over the extremities of the body, it removes anything outside of that. So it's just a lot of time, if you want to cut away a whole part of it, a lot of you will draw a closed boundary around it, and later on when you sketch, your part grows, then suddenly there's a piece sitting in space, and you don't know where it comes from. But if you use this method, it's cutting everything away on that side. It doesn't matter what you do.
Another feature of the thin feature I want to show you guys is to actually revolve. And we are actually going to use a revolved thin feature. So as you guys can see, this sketch here is not closed. Obviously, there's no line. So if I choose to go and use the revolve and select the sketch, it's going to ask me, do I like to close the sketch? For all intents and purposes, we're going to say no. We want to use the thin. And you'll see that it makes a thin feature. Looks a lot like a flower pot. And you can still go and change the settings here if you'd like. I'm just going to go and click OK.
Okay, not a surface revolve, it's a thin feature. It gave thickness to that line. But the trick, and that's why we're specifically showing you revolves, because often in a revolve we'll sketch a boundary and we'll have a construction line there that's the midpoint, and then that question pops up. You've all have seen it probably. It says, do you want me to close the sketch? And you say yes, because you know that's what SOLIDWORKS is going to do. You don't even think what it does. But you override the default by saying, no, don't close it. I want it to be a thin feature. Okay. So the main thing that we want to communicate is that different features will react differently based on intelligence and how it try and understand what you want to do. Okay. This is not AI. This is just default behavior that's built into it. It's been around in the software all the ages. Okay. But if you look at the different features, override the default settings, you can manipulate the results that you get. Okay. So take this further. Don't just think about thin features. Take this principle further into all your features and all your design methods. And go and look at the options and look at what is the default behavior of a feature.
Okay, I want to show you guys something I'm sure you guys are going to use. How many of you guys use step files into your SOLIDWORKS? Okay, probably a lot. How many of you guys actually use it in assemblies? Have you guys ever tried to use specific parts out of a step file? A bit tricky.
So,
Yes.
do you have a certain situation where you get a step file, a massive assembly, and you only want a certain, some of the parts out of it? You don't want the entire thing. Okay, there's a few nods. Okay. We're going to show you how you can easily get to that. Just before you continue on there, before you click, you're clicking too fast for me. Again, default behavior of the file open interface. So if you go file open, here at the bottom, you can see this will change. Let's quickly just go to all files and select a SOLIDWORKS file. Have you got a SOLIDWORKS file close by?
I have in the assembly.
Okay, just click on the assembly, don't. Okay, so we're going to come back to this. We're going to continue on, but what I just want to show you, can you see that the options at the bottom completely changed? Okay, you guys are used to it. You go file open, click, select your assembly, and there's information there. So now go back to the step file. Can you see that the bottom now changed completely based on the type of file that I'm looking to open? Okay, select your step file.
Okay, I select my step file and I want to enable filter. Very important when you try to do this. So I'm going to go and click enable filter here. I'm going to go and open this. Okay. So it won't show a preview originally of the step file you're trying to import.
So on the top it actually says no preview generated. Filtering can be performed from the feature manager. So what it does, it first only loads the structure of the step file. So whatever you received, it gives you that. And if you know the file names of what you want, you can now actually go and... So in the past, if you wanted to find a few parts out of a massive step file, you had to open the whole thing, wait for it, and there's some problematic files in there, and so on. And now, if you load it with that little filter at the bottom there, then it will just load the structure, and now we can just select some of the files.
Okay. So, Iris, if you don't mind, I'm going to go and generate a 3D preview.
Okay.
So I'm just going to go and generate a 3D preview. For instance, like Iris said, all the names are here, but if we don't know actually what the names are for, 9045001, that doesn't mean much to me, but if I see it, maybe I can relate to it. So if I go and I select, let's say, for instance, these two. These two is what I want to actually import. I don't want the rest. Okay. So I go and select these, and I can go and right-click, and I want to say exclude other components. You'll see that the only two in the feature manager tree, is going to be the two that is selected. From here on out, I can go and import the model into a normal file, and from there I can go and put it into assembly.
I've actually seen a few guys grabbing pens and making notes of this. So, who of you know about that filter? Does anybody know about that? It's been introduced about a year or two ago. It's been enhanced again. So look out for that. And again, one of the main things that I want to make you, we just use software on reflex. So, and that's the theme of what we show you. With thin features, using something, there's default behavior. So yeah, we just ignore that bottom of that open window. So go and look, educate yourself with the options there. Okay, that's where the useful tools lie.
Let's go to another assembly tips and tricks that I want to show you guys is actually simplify configurations. You agree with this?
Yes.
So if I go to my SOLIDWORKS again and I open up an assembly.
So we can actually skip the assembly and open up the body of that flashlight, that
Only
green
the body.
part.
Okay.
So what we want to show you here is if I've got a big assembly and I know there's a part in my assembly with a lot of detail on that part that slows down my assembly. Okay. But I can simplify that. I don't need that information like this. So Rocco, you can go ahead and create a configuration for us.
Okay. So I'm just going to go and create a new configuration for this. I'm going to use my name just to make this simple. Now I want to go and simplify this model. This is not really a very complex model, but just for the wise and non-wise, let's just go and simplify this. So I want to go and use this wrap here. So you guys see on the body here, I'm going to go and suppress this. So see that is nice and smooth.
Okay.
And I want to go and actually save.
Just activate the default configuration again, just to prove our point. Okay. We set it back to that configuration. All we did was we created a configuration that's simpler.
And I'm going to have my own configuration here. I'm going to save.
Rocco, let's move to the opening of the assembly. You can start browsing that side. Go to File, Open.
Just close. Looks like it's saved.
Yep.
And I'm going to open up the assembly where that part is from. So I'm just going to go and filter my top level assembly.
Okay. Again, when he clicks it, what we see is the options at the bottom change. We're quite used to that. There's lightweight, resolved, all those kind of things. But there's a few options that you guys probably never use that we want to introduce quickly.
So for all intents and purposes, we're going to have to select that simple configuration that we made. So I'm going to have this on resolved. I'm going to use my large assembly settings. And for configuration, I'm going to use the advanced. Okay. From here on out, I can open it. And it's going to give me a pop-up here. So it asks me, use specified configuration for part references when available. So if I have an assembly with 4 configurations or 4 different parts with a configuration that is simplified. And I
Okay.
can go and name them simplified.
You called it Rocco. Eh?
Yeah.
So activate it and then set the configuration name that, just to prove it for you guys here. So what it does is when I activate that option, there's a few options in there. So it's because I've set it to advanced, then I say open, it brings up the screen to me. Okay? Then we're going to use this option and we're going to say, in this assembly, look for any parts that might have that configuration in there, that configuration name, and open it with that configuration active in my assembly. Okay. So normally we'll use something like simplified. There's a default option, simplified as well. Just makes things a lot faster.
Thank you, it is. Okay, so I'm just going to go and click OK.
And can you see there that that's now opened? It's a simple example, but we just wanted to show you. So if you know there's a part that's hampering you from opening an assembly, go and open that part, simplify it, create, don't call it Rocco. You can if you like the guy. He's actually a very nice guy. But call it simplified, and then when you open it, use advanced. If you get stuck, ask us how. But what we just did, we specifically, and what I made him do is save it in the default configuration again, to show you. That's what the assembly lost. It didn't matter, actually, because the assembly was saved in that configuration. But in that advanced setting, I can force that. Okay. Very useful tip.
Is it a resource problem or it's a simple one?
He's asking about using references, designing parts in context, references, and moving things or whatever. So there's no problem with the software to handle it. It's our ability to manage all those files. We can mess that up very quickly. So it's a very good design tool, but I would say break the reference and redefine that file in its own right, because then you can move that and they're not connected anymore. If you think it's doing something that it's not supposed to do, mail support, and then we can analyze the file. You can take it away, Angelique.
Okay, so hi guys, I'm Angelique. I'm also one of the applications technicians here at MECAD. I'll be doing Visualize and touching on PDM just a little bit because our time is kind of up. So first of all, looking at SOLIDWORKS Visualize. For those of you who use it, it comes with your professional and your premium. When you buy SOLIDWORKS professional and premium, you get Visualize standard with it. So use it if you need to. Okay. So SOLIDWORKS Visualize default template is my first tip that I would like to show you, and it basically is just when you create renders, most of the times you need to use the same backgrounds, lights, reflections, cameras, appearances, all those things. You need to go and set that up all over and over and over again. And this is quite repetitive, takes most of your time up because, I mean, the renders, you just let it run in the background. You have to go and set up that by yourself. So I'm just going to quickly show you a video that we have made. Obviously, we can't run renders in real time. It might take too long. But basically, when we create the templates, it is very easy. You'll see here that we have, I'm just need to double check that this thing is working. Okay, I'm just going to explain it to you because I don't have now that there. But basically, when we would like to create a template for Visualize, it is very simple. It is just the same as you would in SOLIDWORKS itself. So you would go and obviously remove all of the models because we cannot use the models in a template. But you can keep the background. You'll see that we have currently that warehouse in the background. We have different lights that we have set up for this already, and then we can have some appearances in there as well. You'll see that there's appearances, scenes, and cameras. These things we can keep for our template. To save it as a template, you're just going to remove the model, save it out as a project, and then in your tools there is an option to go and save it out and choose this to be your template always. I unfortunately cannot show you the video now because obviously it'll break when I get here. But when you then go and import a new, let's say, heavy machinery model, unlike this one, if you import it into SOLIDWORKS Visualize, it'll use the same template again, which means you'll have the warehouse in the background, you'll have the same lighting. Obviously, the only thing you need to change is the cameras. You need to go and move them around and make sure that they are obviously looking at your model. And if you want to change some lights and so, as well.
Angelique, what I just want to mention on that, and I want to ask you, using Visualize quite a bit, I believe, do you use templates? Okay, so that is just one of the most overlooked things, that every time that you do Visualize, it's a nice feature, but that's not what we do day in, day out. And then we go and reset all these little settings. So go and save your preferred settings that gives you a good result. Save it as a template. If you struggle with that, just pop us a mail. Again, support@mecad.co.za. It goes to our entire team. That mail goes into our CRM system, automatically generates a ticket for you. So there's traceability for you on that. And then we can help you out with setting up templates with that. Okay, massive time saving on Visualize. So just quickly, you mentioned in the beginning that you get Visualize Standard with every professional and premium license. Who's got professional and premium licenses? Okay. Do you all know that you have Visualize? Okay. Visualize Standard. Okay. Do you know where to get the serial number? From MECAD.
From MECAD.
Correct answer. Okay. You won't get that by default. Mail us again and request your serial number. We will send it to you so that we can assist you with that as well. Okay.
So this is just a quick explanation on the performance, the CPU side and the RAM side when it comes to simulation. It also goes to the CAD side as well, but mostly focused on simulation. On the CPU side within SOLIDWORKS, most of our operations depend on a single core. Okay, so when we look at a single core for performance, we're going to look at our clock speed. If you open up your task manager and go and find the clock speed, you'll see it's going to be either between 2 and 3, or it's going to be just below 2. But when we look at a good computer, it's going to be between, let's say, 2.5 and 3.5. This is a great computer to run simulations or renders even when you do Visualize. And even for your CAD, this would be really, really acceptable. But if it is, let's say, around about 2 gigahertz, it's also fine. Your SOLIDWORKS and simulation, everything will work perfectly.
I want to jump in there as well.
Yes.
So when it comes to CPUs, and I had a few fights with a few customers. Yes, if you go and look, it does use multi-threading. If you look at your processors, you'll see the others. But you will still benefit, as Angelique explained, from a higher single-core clock speed. Okay. Don't go and use refurbished servers with extremely good processors. They're designed for server applications. I've had a number of customers who the IT people will sell them this brilliant machine for a good deal. It's a Dell Precision, but it's actually set up for a server. Okay, but it's got slow clock speeds, multi-core functionality. Okay, you will not get the benefit out of those machines. So please do not buy those machines without speaking to us, that we check it for you.
Then on the RAM side, this does not necessarily have to do with your performance directly, but as SOLIDWORKS is solving your simulation or running your renders, it stores these results in temporary files, and this requires you to have sufficient RAM to store that. Otherwise, SOLIDWORKS will warn you that it is running out of memory, or it can even terminate. Okay, and then you have to go and do all of that work again if it has not automatically saved. So make sure that that is also in place. And then if you didn't know, you can increase your PC's RAM size using virtual RAM by increasing page file size. This allows you to use a portion of your hard drive as RAM. So if you have a hard drive of, let's say, 120 gigs, you can use 60 of that gigs as RAM, as memory. Okay, so this is available. Obviously, you can go and ask your IT to help you assist that, or you can just Google it. It's quite simple to just turn that on. But yeah, very simple. RAM is needed. Doesn't have anything directly to do with the performance, but yeah, you need to have sufficient.
Again, I'm not going to recommend that you run 8 gigs of RAM anymore and run a big page file for your normal modeling. Obviously, that hard drive is much slower. Remember, the RAM is a very high-speed memory, and your hard drive is a much slower speed. But if you do a massive render or simulation, and it needs to create a lot of files, Okay, speed is not necessarily the big thing for accessing that information. It's just creating a massive amount of information. It's going to solve it again. It's going to recalculate this. It's looking for storage space in RAM. Okay, and there we do have a benefit by increasing the page file, and it will go and store on your hard drive as well. So you don't have to have, if it's not a machine that's set up specifically with a lot of RAM for simulations or renders, you can benefit from that.
That is then the first tip that I have for you, just to quickly explain CPU and RAM. These are just some pictures that we got for CPU there, where you can find your base speed if you look at the picture. If you open up your task manager, you can see the base speed, and then adding the virtual memory is on the other side. The next tip that I have for you is, this is simulation side. So in Mesh, we are going to use check entities and then Mesh diagnostics. These are two different tools that do the same thing. And basically, we're just going to go and check for short edges when we do simulation. So when we would like to run a simulation, obviously we need to go and add a mesh there and onto this model. And you'll see that this pattern that we have created, obviously it's not perfect. But when looking at it, you can see that it's going to give you some problems. Sometimes you don't know where the problems are, and therefore we would need to go and find it. So to find it, the first way, the quickest way, would be to use the check tool. This we use in surfaces as well when we try and check for open faces. When we do not know why this thing is still a surface, we use this tool as well. So for now, I'm just going to, instead of checking for invalid faces or edges, I'm just going to search for short edges, sorry. Okay, I'm going to click on check. Just going to move this little box away, and then when you click on the results list, you'll see that all of these edges on this MECAD basically label is short, and wherever we have these short edges, the mesh needs to be finer in that area, otherwise it will fail. That's basically it.
We call short edges the passion killer for meshing. So if you do meshing, it's a very nice tool to identify beforehand, before you even take it into simulation, where you're going to run into problems. And as Angelique said, we created this on purpose to create something like that. If you test this file and it's got textures on, or logos or things like that, that's actually extruded or cut, that's not going to affect the strength of the part. So you want to go and clean up that file. So the check tool is one of the first things that we do before we try and mesh something.
So then there's just another side to it. If you are more comfortable with using simulation itself, we have created a study over there, and then just in the mesh tool, we can go and create the mesh. It's going to make sure all of my options are fine, and then click OK. Okay, it's just going to quickly run it. It's not supposed to take very long. So going through the pattern, L pattern 1 is the part that we have, it's the solid body, and you'll see that obviously it's saying that the mesh is going to fail because of this part. It then tells you 3 different options that you can go and try and fix this. Okay, I'm not going to read through all of that, I'm just going to go to this mesh failure diagnostic tool. Very nice, you'll see that it shows you the following bodies failed to mesh. This is L pattern 1, it shows you all of the different faces. I'm just going to minimize that to show you that it even shows you all of the different edges. The nice thing about this tool is the simulation advisor, by the way, is what it is called. This will then give you a few options down here of how you could fix this, like creating an independent mesh. It's going to show you which bodies failed, which means you can then go and simplify that, and a few more. This tool also then has other inputs like study, bodies and material interactions, can also help you to read through the results of the simulation and help you to interpret what all of that means. Just a quick tip or tool that you can use when you start to do simulations and maybe learn about simulations and things like that, that you can use before obviously running that whole simulation.
Thank you very much, Angelique. Let's give Angelique a round of applause.